All right, welcome back to Mrs. Rocket's Algebra Lessons. Today we're going to be doing concept number 11, which is division properties of exponents. So we've been multiplying and we've been taking powers to powers, and now we're going to see what do I do when I have something with the same base with a power over another thing with the same base with a power. So if you take a look at the very first problem, 4 to the 5th over 4 to the 2nd, notice over here I've expanded it out. There are 4 times 4 times 4, 5 4s there. And down here, there are 2 4s. So now if you think about division, 4 divided by 4, well, that's 1. And another 4 divided by another 4 is 4. So technically, these guys cancel out. So I'm just going to go ahead and cross those out. Those are 1s, because 4 divided by 4 is 1, right? So I could essentially put a 1 up there and another 1 up there. And it's not really necessary because you've got all these other 4s up here. So 1 times 1 is just 1. And then 1 times all of these 4s, well, we've got 3 remaining factors of 4s left over. We could rewrite that as 4 to the 3rd. And then if you go back here and you look at the powers, if I subtract the powers, 5 minus 2, I get 3. So let's take a look at the next one. My little ducks are here in the background. I thought you might like to hear them a little bit. So this one right here, x to the 6th. I'm going to go ahead and write x times x times x times x times x times x. 6 x's on the top over x to the 4th means x times x times x times x. So if you think about it, I could cross off a total of 4 x's because x divided by x is 1. So those are all 1s. And then I'm left here with 2 x's. I can rewrite that as x to the 2nd power. And if you go back and look at your exponents on your x's, you could subtract them. 6 minus 4 gives you 2. Now let's take a look at the next one. I've got 2 variables now. I've got x's and y's. So x to the 4th is 4 x's, x times x times 2 y's. We've got 2 y's over 3 x's, x times x times x times 1y. And so if you look, the x's, they're the same number. Those can cross out to give me just 1 x. And then we can cross out these y's left to give me 1 y. So that just means my final answer would be x times y, because we wouldn't need to write x to the 1st, y to the 1st, because everything is to the 1st power unless we put a different exponent on it. So now on x, if you look at the exponents we had on x, we had a 4 and we had a 3. And so 4 minus 3 gives us 1. And then on the y, we had 2, and this would count as 1. 2 minus 1 is 1. All right. Let's take a look at ones with numbers. So the big numbers in front of these variables are called coefficients. So I've got a 10, and that's just being multiplied by 5 x's. So I'm going to write 5 x's down and 4 y's. And then on the bottom, I have a 2, and that's being multiplied by 2 x's, and then another y. So now if you look at the 10 over 2, well, what's 10 divided by 2? Well, 10 divided by 2 is 5, right? 5 over 1. So that would reduce. So the regular numbers, you just reduce them like regular. 10 over 2 is equal to 5 over 1. We can cross off these x's, we can cross off 2 x's, and we can cross off 1 y. So how many x's am I left with? I'm left with 3 x's. How many y's? I'm left with 3 y's. And then I have a coefficient of 5. So my answer, we're not going to write it as 5 over 1 because that's just 5, would be 5 x to the 3rd, y to the 3rd. And now let's go look at the x's. The x's had exponents 5 minus 2. 5 minus 2, what do you know? Gives me 3. And then over here, 4 minus 1, remember a variable that stands without an exponent counts as 1. And then you get 4 minus 1. Well, that equals 3 as well. Catching on? All right, so now let's take a look at the next one. For the next one, you've got coefficients as well. You've got 5 and a 15. And then you multiply 3 x's on the top and 3 y's on the top. and then you have another x on the bottom and 2 y's on the bottom. Now, this 5 over 15, it matters that the 5 is on top and the 15 is on the bottom. Reduce that fraction. That's 5/15. 5/15 reduces to 1 over 3. So now look, that 3 down there, it has to stay in the denominator, okay? The 1 has to stay in the numerator, but remember when we multiply by 1, by all these x's and y's, you don't have to have the 1 there. You can leave it there if it's helpful. So now we're going to cross off 1x and 2 y's. The number of factors remaining on the x's is 2, and the number of factors remaining on the y's is 1. So now when I write this, you could write it as 1/3 x to the second y, but typically when you have a denominator, you put the denominator just on the bottom, and what's left on the top is 1 x to the second y, but I don't need the 1 because 1 times all of this stuff. Remember the distributive, or not the distributive property, the identity property says 1 times anything gives you that same thing back. So I'm going to do 1, or just x to the second y over 3. You could put the 1 there, but it's not necessary. Okay? So now the x's, the exponents on my x's were 3 and 1. 3 minus 1 gives me 2. And my variable, my exponents on my y were 3 minus 2. And 3 minus 2 leaves me with 1y. All right, go ahead and stop the video and see if you can try this next one. All right, welcome back. So again, I'm going to use my fraction bar here so I have a little bit more room. I've got 6 over 9. So 6 over 9. And then I've got 4 x's. 1, 2, 3, 4. All being multiplied by 3 more y's. Put my little dots in between here. Times 4 more x's. And a y. And so now let's take a look at 6/9. That's a fraction. Can it be reduced? Yes, you can divide the top and the bottom by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So you have 2/3 there. All 4 x's cancel out. You have no x's. And then you cross out 1 y. So we have 0 x's. We have 2 y's. So now we're not even going to write the x's, right? Hence, x to the 0 equals 1. We'll talk more about that next class or in a couple days. And now let's write my answer. So 2/3. I'm going to put a 2 on the top. The 3 has to go in the denominator. The 2 has to go in the numerator. You don't have any more x's, but you've got y squared on the top. And we just make it one big fraction. 2/3 times y squared does mean the same thing, but we typically just don't write them that way. Okay? So now go back and look at your exponent on x's, right? We have 4 minus 4. Well, 4 minus 4 is 0. And then on y, you have 3 minus 1. 3 minus 1 is 2. And so that's what's left over. So now my conclusion. What do you think it is? When dividing powers with the same base, it has to be the same base, what are we doing with the exponents? We are subtracting. It's just like that's why I was doing this over here. You subtract the exponents. Let's do some examples. So, like usual, I would encourage you to stop the video, try the examples, and then fast forward through my explanations and see if you got them right. And then if you get them wrong, then go back and listen to my explanations. You don't have to sit and listen to all my explanations if you got them right. So, this first one, I'm going to just simply, they both have the same base. I'm going to subtract 9 minus 5, and I get m to the 4th. Done. All right, this next one. The coefficients, 8 over 4, we don't subtract those. They're the big numbers. They're the numbers that are just being regularly divided. 8 divided by 4 is 2. Okay, then look at the b's. We've got b to the 3rd over b. So 3 minus 1 is 2. So I've got b to the 2nd. And then we take the a's, a to the 6th over a to the 4th. That leaves us with a to the 2nd. Now typically we write our answers in alphabetical order, so usually you would see it as 2a to the 2nd, b to the 2nd, and that would be my final answer. So this next one, 24 divided by 6 is 4. You don't have any k's to cancel out, so it's just k, and then h to the 2nd divided by h, you cancel 1 out at the bottom, left 1 at the top. So if I want to write this in alphabetical order, I'm going to write 4hk. It's not wrong if you don't put them in alphabetical order. I'm just trying to be consistent with what you're going to see most often. Okay, next one, 12 over 18. Those are coefficients. They're being multiplied by everything, and then 12 over 18 is being divided. So 12 over 18, we're going to reduce it like a regular fraction. So we're going to have something on the top and something on the bottom. So I'm going to divide 12 by 6, and that's going to leave me with 2 on the top. 18 by 6, and that's going to leave me 3 on the bottom. The w's, they cancel it all together, right? Because they're both, you've got 4 of them, so you're left with none. And then 6 minus 3, you're canceling out all 3 on the bottom to leave you with 3 v's on the top, so that's 2v to the 3rd over 3. You could write it as 2/3 v to the 3rd, but that starts to get complicated when we start working with them by like adding and subtracting them to things. And I always like throwing in some with just variables, so to make sure that you know the rule. So if you look here, so I've got an exponent of f and c, and they're both attached to the same base. Because these guys have the same base, my base is going to stay h, and then f and c, because it's division, the rule is to subtract the exponents. So I'm just going to write f minus c. So it's h to the f minus c, and it has to go f minus c because you always do the top minus the bottom. Now the next one, a little bit of a trick question. You have the same exponent. Let's think about that for a second. You have the same exponent, that doesn't mean anything. What matters is you need to have the same base, right? So this would be like doing something like 3 to the 2nd over 4 to the 2nd. Can I cancel any of that out? Can I write like 3 times 3 over 4 times 4 and cancel any of that out? No, I absolutely can't do that at all. So there's really nothing I can do with this one that's already simplified. You could take it back to its original problem, which would be like m over k, the whole thing in parentheses, to the a power, but you don't actually know anything about that yet. So I'm going to cross it out, and we're going to move on to the next section. All right, so this next one is a power of a quotient. So you're actually taking a quotient to a power, or it looks more like you're taking a fraction to a power, which actually you kind of do know how to do something with this. We've just written it out so far. So like here, if I'm taking 2/3 to the 3rd power, well, that just means you're doing 2/3 times 2/3 times 2/3. And then the number of factors in the numerator are 3, right? You've got 3 2's, and the number of factors in the denominator is 3. You've got 3 3's, right? I could rewrite that as 2 to the 3rd power and 3 to the 3rd power, which of course we would simplify this to 8 over 27. But right now we're just going to focus on what do you do with that power on the outside of the on the outside of the parentheses. So the next one, 4 over m to the 2nd. Well, just think about what that means. You know what that means. It just means you're doing 4 over m times 4 over m. So how many factors do I have in the numerator? Well, I've got 2 factors in the numerator. I've got 2 4's. How many numbers in the denominator? I've got 2 factors of m, so I've got 2 of those, right? I can rewrite that as 4 to the 2nd over m to the 2nd, which does simplify to 16 over m squared, but I want you to focus on this one for right now, because we're trying to figure out the rule. So the next one, y over x to the 3rd power. If I write that in expanded form, that's y over x times y over x times y over x. Well, how many numbers do I have in the numerator? I've got 3 y's there, so I've got 3. Number of factors in the denominator, that's 3 as well. How can I rewrite this? Well, I can rewrite it as y to the 3rd over x to the 3rd, and we're done with that one. Can't do anything more to that. All right, so now what if I've got multiple things going on here, right? So I've got 2 over x to the third over 3y squared, that whole thing to the second power. Well, what that means is negative 2x to the third over 3y to the second times negative 2x to the third over 3y to the second. So now, how many factors of negative 2x to the third do I have in the top? I have 2. How many factors of 3y to the second do I have in the bottom? I have 2. So now let's think about this. I've got 2 sets of negative 2x to the third. I've got 2 of those, right? Over 3y to the seconds, I've got 2 of those. Now think about, I'm going to take this to the next little step here, and I might write it down here. Think about that. Remember your rules with exponents. If I bring that in, doesn't that mean negative 2 squared x to the, what do I do here? I multiply those guys. X to the 6th over, bring that 2 in to the 3, so it's 3 squared over y to the 4th. That could be simplified to 4x to the 6th over 9y to the 4th. Now this guy is what I want us to look at. So now my conclusion. When a quotient is raised to a power, what do we do? Well, we apply the exponent to all of the factors in the numerator and the denominator. So let's write that. Apply, which lots of people like to say you distribute. It's not the distributive property. It's a lot like the distributive property. That's why I'm using the word apply. So you apply the exponent to all factors in the numerator and denominator. All right, let's try some. Again, I encourage you to stop the video and then tune back in, see if you got them right. All right, all I do is I take that 5, you got to put it on the top and the bottom. So I'm going to make this m to the 5th over 2 to the 5th. Well, I know how to do 2 to the 5th, so let's simplify it. So in these now, I want you to fully simplify them. So we're going to do m to the 5th over, well, 2 to the 5th, 2 times 2 times 2 times 2 times 2. If you can't do it in your head, I like to do it this way. Make that a 4, make that a 4 times 2, right? So you can do 4 times 2 is 8, times 4 is 32, or 4 times 4 is 16, 16 times 2 is 32. So m to the 5th over 32. All right, the next one. You've got multiple things. That little 3, it has to go on every single factor. Every single factor, including the 3. Don't forget that 3. It has an exponent of 1 on it right now, but I'm taking it to the 3rd power. So it's going to be 3 to the 3rd power, a to the 3rd power, b to the, what do we do with those exponents? Multiply. B to the 9th over c to the 12th, d to the 3rd, and then naturally fully simplify that. And if you wanted to fully simplify that to 27 at the very beginning, that's totally fine. So we've got 27, a to the 3rd, b to the 9th, over c to the 12th, d to the 3rd. All right, this next one I'm just going to say is 9, whoopsie, 9, k to the 2nd over h to the 2nd. Where'd the 9 come from? I did 3 to the 2nd. I brought the 2 to the k and the h. Done. 5d. You have this exponent out here. What do I do to it? I have to apply it on everybody. So I get 5 to the x, d to the x, over 2 to the x. That's really me just seeing, do you know how to apply the rule, right? We don't know what x is. We can't really do anything with it. All right. All right. So flipping it to the back. These ones are a little bit different Because take a look at how many x's you have on the top for 6a and how many x's do you have at the bottom. I want you to think about this for a second. Have we ever done anything with negative exponents? We haven't, not yet. So I'm going to tell you right now how to deal with this. So like, just for example, some of you might look at this and say, well, I'm going to subtract 6 minus 9, and 6 minus 9 gives me negative 3. So my answer is 2x to the negative third. Granted, that is correct, but that is not fully simplified. Not very many people in the real world know what negative exponents are, and we're going to talk more about negative exponents in the next couple of days, but right now we are not going to leave our answer like that. So I want you to think about, we are subtracting, but think about canceling things out. So if I were to write this in expanded form, it would be 2 times 6 x's. I know that's a lot of x's, and it's kind of annoying that I'm making you write that many x's, over 9 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9. I want you to think about that. Remember at the very beginning of this, I was showing you could cancel them out. Well, let's think about it. I can cancel out a total of 6 x's. What does that leave me? That leaves me with 2 x's, but where are they? They're in the numerator. So whenever you get negative exponents, I want you to think about it this way. Going through and thinking, okay, I have 6 on the top and I have 9 on the bottom. I'm canceling out all 6 on the top. How many's left over? 3 at the bottom. That x to the third, it has to be on the bottom. So we're going to do 2 over x to the third. Okay? No negative exponents in your final answers. All right? The next one. Let's look at it. So 10 over 5. I'm going to write it out in expanded form first. Let me erase this other stuff. All right. 10 times 3x's times 2y's over 5 times 4x's times 5y's. And now let's look. 10 over 5. Notice 10 over 5 is 10 divided by 5. 2 over 1. Do I need the 1? No. So on the top, I have a 2. Okay? Cross off the x's. I've crossed off all 3 at the top, right? How many does that leave me with at the bottom? Just 1, right? You've canceled out the 3 on the top. You've left with 1 on the bottom. So there's an x on the bottom. Now y's. I can cancel out all 2 on the top, which leaves me with none on the top, and then you take away 2 on the bottom because the bottom's bigger. You're left with 3. So you see how it works? You've got y to the third on the bottom, okay? So moral of the story, if you have more exponents on the bottom, when you go to cancel them out, your exponents are going to be left at the bottom on your base. Same here. This one up here, we had more exponents on the top, on the bottom than we did on the top. So we were left with things on the bottom in the denominator, okay? So this is your final answer. 2 over xy to the third. The 2's on the top because 10 over 5 is 2 over 1. Next one. All right. Again, if you haven't tried any on your own yet, you really should. Okay, so now look at this. 2 over 8. It's not 8 over 2. The 2 is on the top. The 8 is on the bottom. That's 2 eighths. How do you reduce 2 eighths? Well, that's 1/4. I'm not going to put the 1 up there yet. I'm going to put a 4 at the bottom now. Okay? So now I've got a to the 4th over a to the 6th. If you need to write it out in expanded form and cross things off, go for it. But when you do that, you're going to cross off all 4 a's at the top, and you're going to be left with how many at the bottom? 2. So I've got a to the 2nd. And then I've got b to the 6th over b. Well, this one, there's more on the top than there is on the bottom. So 6 minus 1 is just 5. So you're left with b to the 5th on the top, because it was top heavy, right? There is more on the top than on the bottom. So you're crossing off the 1 on the bottom, you're crossing off 1 on the top, but you're left with 5 because you had a total of 6. So your answer here is b to the 5th over 4a to the 2nd. And if you put a 1 there, technically okay, but it's not in simplest form. So you want to try to remember to leave those 1s off. It's just b to the 5th over 4a to the 2nd. All right, 6D. negative 6 over 4. This part right here, please notice that that's an improper fraction, negative 6/4. Do not make it a mixed number, because once you have a mixed number and then you're trying to throw variables in, you don't know if they go on the top or the bottom, and then it's not how we do things. We want one fraction. Negative 6 over 4, both of those numbers are divisible by 2. We're just going to reduce that like a regular fraction, so it's negative 3 over 2. How many x's am I canceling out? There's one x on the top. I'm going to cross that one out. I'm going to take one away down here. I'm going to be left with 8, right? So it's x to the 8th. I've got one y down here on the bottom. I'm going to take one away from up here because you're canceling that guy out, right? You've got 7 y's on the top, 1 y on the bottom. You're left with how many? 6. So it's y to the 6th. So essentially you're subtracting, but keep in mind, if you get a negative exponent, it technically goes on the bottom. Or another way to look at it is what I'm saying. If there's more on the bottom, when you cancel them out, they stay on the bottom. If there's more on the top, they go on the top. And this is a 6, not a B. It looks a little like a B. Okay.
The rest of the sheet is for homework. Good luck!